And now we're going to add in 3 additional trig ratios. Okay, so, and they're nowhere on your formula sheet. You have to remember them. But there's a good connected relationship between the ones you know and the ones you're about to know. So, sine, pretty straightforward. It's on the back board. If you forget, sine is opposite over hypotenuse. And the first time you saw that was grade 10. And cosine is adjacent over hypotenuse. And really, we know that on the trig, on the unit circle, sine theta is equal to what? What coordinate is sine theta equal to? Y. And it would be y over 1, but we don't need to put that. And we know that cos theta is equal to the x coordinate, right? Tan is something else all by itself. So tan theta is opposite over adjacent. But we also write tan theta as sine theta over cos theta. Right? So we know that already. That's knowledge that we already have. Okay, so here's the knowledge we're about to learn. Cosecant. Cosecant is the reciprocal function of sine. So, secant theta is the reciprocal function of sine. Anybody want to take a guess what secant is? Reciprocal function of cosine. So, secant theta is the reciprocal function of cos theta. And cotangent, not a huge shocker, is the reciprocal function of tan. And we're going to write this one just another way. So cotan, if we know that tan is sine over cos, we know that cotan is the reciprocal of this. So what would that be? Cos over sine. Okay. Fun stuff. So really we're just flipping stuff. Biggest mistake people make when they're learning this is that they don't see the relationship. It's sine and cosecant. So they're different letters. Okay? Cosine and secant, they're different letters. People tend to put sine and secant together because they're the same letter, and that's not correct. It's just one of those memorization things, so you have to remember that they have different letters. Okay? So sine goes with a cosecant, so S with a C, and then C with an S. And then I think cotan is pretty self-explanatory. Just to mess with you. Just to mess with you. I have no idea why they named them the way they did. If you're, wait till we graph it, because then we do lots of stuff with tides, moon phases, things like that.
Oh, gravity.
Gravity, all that sort of stuff. So it's getting you prepared for the graphing part of it, which is a little bit more. Will you use this in every day? Probably not, but it's training your brain to think and apply new knowledge. Okay, so we did this on our quiz. The quiz? Exact values. We talked about this in grade 11 as well. Exact values means leave it as a fraction, no decimals, right? So here, again, exact values, we're going to leave it as a fraction. And we'll probably have a radical in it just for funsies. So what is cos of pi over 3? right? So if we come over here, cos of pi over 3, the x value is 1 over 2. So there's no math to do on this one. Like there's no calculation, but there's a lot of remembering. Okay, so secant of pi over 4. So what is the reciprocal function of secant? What does it match with? Cosine. So what I like to do is I like to do cosine of pi over 4, because that one's on the unit circle. That one is on the unit circle. And I know cosine of pi over 4 is root 2 over 2. So I know that. So all I have to do for secant of pi over 4 is flip the fraction. Right? So this is nice and easy. This is a helper piece. That here is a helper. That is not required for you to write, but just so you can see my thinking process, that's how I relate those reciprocal functions. So I figure out where the sine or the cosine or the tangent is, because I know those, I've committed those to memory. Once I know that, I just flip the answer. Okay, cosecant of 2 pi over 3. So cosecant relates to sine. So 2 pi over 3 is in quadrant 2, and the sine of that is root 3 over 2. So this is going to be 2 over root 3. Pretty straightforward. You're just flipping stuff upside down. Cotan gets a little bit frustrating just because you got to do the math for it, or if you're good at remembering, that's not a bad thing either. So cotan of 5 pi over 6. So cotan of 5 pi over 6, you can do it a couple of ways. I know that if it has a denominator of 6, tangent is 1 over root 3. Do you guys know that? No? Okay. I know if my angle has a denominator of 6, my tangent will be 1 over root 3. And I know that from my Claudius data table.
Oh, no.
Well, it's just a way to remember it. If I don't know that, like if I haven't remembered it, then I probably would abandon my memory and I would go to that cotan of theta is equal to cos theta over sine theta. So I would go there first. So if I don't have it memorized, I would go there first. I'd find 5 pi over 6, which is here. And I would do the division. So I have negative root 3 over 2 divided by 1/2. Right? So if I don't have it memorized, I'd go to actually mapping it out. How many do you think you may or may not end up screwing this up of what tan is and what sine is? Anybody? That's probably like an easy thing to do. So you got to figure out a way to remember which one belongs to what. Okay, cotan of negative 3 pi over 4. No. I have no idea what to do with a negative angle. Negative angles aren't on my unit circle. I don't know where I am. So the first thing I'm going to do is I'm going to do a positive coterminal angle here. So how do I do a positive coterminal angle? Add 2 pi. So I'm going to have negative 3 pi over 4 plus 8 pi over 4. And why 8 pi over 4? Because that is a full rotation. And I'm going to be looking for cotan of 5 pi over 4. It ends in the same place. I'm going to get the same answer, but it's just way more friendly. What quadrant am I in 5 pi over 4? I'm in quadrant 3. And we have no information for quadrant 3. Didn't do that, but that's okay. If I have a fraction with the base of 4, what do I know? I know tangent will be 1, because it's going to be root 2 over 2 divided by root 2 over 2. And when you divide by itself, it's 1. You told me I was in quadrant 3 here. No, pi over 4s are the exact same. Sorry. But that's a good strategy. But pi over 4, the quadrants are the exact same. Or sorry, the coordinates are the exact same. So again, if you aren't remembering that, math it out. And so we're going to take our cosine, which is negative root 2 over 2, and we're dividing it by our y, which is negative root 2 over 2. Because you guys told me in quadrant 3, I'm in quadrant 3, and I know in quadrant 3 my x and my y are both negative. So I know that cotan of 5 pi over 4, my bracket's pretty terrible, is a positive 1. But if you're getting good at memorizing, if that's your superpower, it's not mine. I've just worked with the unit circle lots, so I have tricks to help me. But if you're really good at memorizing, you don't have to show me any of this. If you know that tan, anything with a denominator of 4 is going to be 1. It's going to be a positive 1 or a negative 1 based on where you are in the unit circle. Reciprocal of 1 is just 1. So you don't have to show me this math. You can go right to the answer. If you're confident in your memorization. If you're not, math it out. It really doesn't take that long to math it out. Last one. What am I going to do here? I have no idea where I am. I'm going to find a smaller positive coterminal angle. That's going to be my strategy. I know that the full rotation is 12 pi over 6. So how many 12 pi's am I going to pull out of there? 2. So we're doing some mental math here. So 2, no, 2, 24. 24 pi over 6, and we're going to subtract that from 29. So we're looking for cos of 5 pi over 6. So now we're building in that information about coterminal angles into solving for actual trig ratios. 5 pi over 6 cos, I'm looking at my unit circle over here, it's going to be negative root 3 over 2. So on quiz 1, I asked you, give me the coordinate at that angle. On quiz 2, I'm going to be saying stuff like this. What's cotan of 5 pi over 6? So I'm asking you really specific things about it. Okay, we're building. What? I'll give you a blank one, and then you can fill it in. And you'll have that on your exam as well, like your provincial exam, there'll be a blank unit circle in it. And what I would do even before I'd start is I'd fill out what I need to on that one, while your brain is still fresh. Negative 47 pi. All we're doing is, what are we going to do? Positive coterminal angle. So we have 12 pi over 6. How many of those do I need, Rahat?
4.
This time I need the 4, right? So 48 pi over 6 plus negative 47 pi over 6 leaves me with 1 pi over 6. All right, so cosecant is related to sine, okay? So pi over 6 is my smallest angle. I'm looking for my y value, which is 1/2, but we want the reciprocal of it. So The answer is 2. Okay, next one looks super complicated. Oh, those are supposed to be, those G's didn't come in. They should be multiplication symbols. Yeah, that's a whole new trig ratio. Looks really difficult. It's not. We just got to figure out where we are. You're going to evaluate each one of these, and then you're just going to multiply them together. So where am I at cos 30? I'm definitely here, but am I here or am I here? Okay, so you've answered the question, right? Do I need to do any, so if we know this has a value of 0, do we need to know these two if we're multiplying? No, because anything times by 0 is 0. I mean, you totally can put the values.
You went 15 circles. You want saying he's explaining how you
Oh,
get
yeah.
Yeah.
No. Oh, you're right. Cosine. Cosine. Is its sine is 0.
Ah.
All right. Well, that. Thank you, Anna Ruth, for catching that. So cos 30 is 1. Boo, 0. We could have called her that. Secant of 2 pi over 3. So secant is related to cosine. So at 2 pi over 3, cosine is negative 1/2. So we're doing the reciprocal of it. Negative 2. And then we're doing cosecant of negative pi over 3. Where are you? We're in the 4th quadrant. We're at 300 degrees. Yeah. Oh, hang on. So, yeah. So we've got 5 pi over 3 would be our positive coterminal angle. Because we're going to take right, to find the positive coterminal angle of 5 pi over 3. So cosecant is related to sine. So what is sine at 5 pi over 3? I'm just going to, find your denominator at 3. Find your denominator at 3. This is the coordinate. It's just going to be in quadrant 4 this time. So sine is going to be negative. So it's going to be a negative, right? Because we're doing the reciprocal. And now we're going to go ahead and multiply them.
Does it matter where you put the negative?
No. Does that help? There is a question like this on your quiz.
We make it 0.
Wouldn't that be nice? I think I did maybe on one of the versions of the test.
There's always one that's so much easier than you. Always one from understanding.
Okay, now we're going to do approximate values. My least favorite part. Everybody's going to need a calculator. Everybody's going to need a calculator.
So now we got to do decimals.
Now we got to do stupid decimals.
4.
4.
That's asking a lot of graphics. That's a lot.
Okay, here's the thing. On the provincial exam, 4 is the requirement. 4 is the requirement for decimal places. So on your exam, 4 is what you should be rounding to, 4 decimal places. So we kind of want to make this standard in our everyday lives, doing 4 decimal places. I know it feels not great, but if we practice it in class, we'll feel more comfortable. It'll be old hat, it will be muscle memory to go to 4 decimal places. So that's what we're going to do. Okay, we know right away that there's nothing with denominators of 5 on the exact values. So right away, this is a calculator question. Pardon?
Wow.
It's 30 degrees. All right, so we have a 10 button on our calculator, so that's really great. We can use that. Life's fabulous. What angle measurement is this in your calculator? What is this? These are radians. So we need to change our calculator to radians. So let me grab mine actually says the word radians. Yours probably has an R or a rad on the display. So if you have a graphing calculator like mine, we are going to go to the word, no we're not, we're going to go to mode. And in mine you can see the degrees highlighted, like I'm in degree mode. I got to flip over to radians. You guys should have our DRG button, which you might think stands for degrees, but it's degrees, radians, gradients. And your display should say an R on it or RAD. Okay, don't beat up your calculator.
Why not?
Stop being aggressive with your calculator. Did it? Gentle. Does everybody have their calculator in radians now? Yes? If you are using a phone on the sideways thing, I have no hot sweet clue on how to change it to radians. But I wouldn't recommend that you do that because you're never going to have a phone on the test or quiz. So, all right. So for my calculator, I put in tan first. Is it? Perfect. Okay, perfect. So I'm going to do 5, and I have to use my pi button. 5 pi. Is it 7 pi?
Yeah.
Well, that's good. 7 pi. I got the number right, just in the wrong order. I got to get points for that, right? So I'm going to put it into my calculator like that. You could convert it into degrees if you wanted to, but if you're going to use radians, you need to make sure your calculator is in radians. Whoa. Okay, 4 decimal places. What do I have here? 3.0777.
This is good.
Okay, what's the next one in? Degrees. So what do I have to switch my calculator back to? Degrees. This is the worst part of grade 12, is remembering what mode your calculator is in. Worst part. I have never used gradients, but you will use them in higher levels of math when you go to university. Oh, that is not where I want to be. I want to be in function.
Yeah, thanks for being there for us.
Okay, 260, is 260 a value on the unit circle?
Yes?
Is it? Is it? 260? Yeah, so 260 is a nice round number, but it's not one of the exact values that we use. So pretty straightforward, cos of 260 degrees. I'm using this calculator instead of the other one. What quadrant are you in 260? You're in quadrant 3. What do you anticipate the x value to be? Negative. And if you do it in your calculator, so what am I doing? Cos? Cos of 260. I got a negative answer, and that's what I anticipated getting. And we're going to 4 decimal places, so 0.1736. I got my negative there. All right. I never deal with negative. I never ever deal with negative angles. I always use a positive coterminal angle just because my brain doesn't think in negatives. So if I do a positive coterminal angle of this, where am I going to be? 290. In quadrant 4. Cosecant is related to what? Sine. Okay? So cosecant is related to sine. We do not have a cosecant button on our calculators. So what we have to do is we have to do sine of that first, and then we have to take 1 and divide it by our answer. Right? So in my calculator, I'm going to do sine of 290. And I'm still in degrees, so I don't have to switch. I'm done. I'm done. I'm done fighting with it. There we go. All right, so that's sine of 290. That's not what I want. I want the reciprocal of that. And it's a decimal inside of a fraction, which makes me just not happy. But all we're going to do is put that as the denominator. So this is going to be 1 over that. I need to use all my decimal places, ladies and gentlemen, because I'm not to the final answer. So I have to go 1 divided by, and I can pick the answer from the line above. Hopefully you can too on your calculator, or you'll have to type in all those digits. So the only thing you round, you use all your decimal places, the only thing you round is your final answer. So you have to use all these decimal places. So that's going to be, so maybe I should write this out for the people who aren't here. So that equals I'm not going to write out those decimals all again, so I'm just going to use my ellipses for that one. I'm just going to write out all my steps so we remember how to get this. 1 divided by my answer. So my answer is going to be a negative 1.0642. You guys got it? Easy peasy. Okay, do the next one.
So high. Where do you get this video?
So out of pocket.
Anybody volunteering to do it on the board? I'm sick of everything. No volunteers to be on board?
What? For how? What do you do?
I was wanting to think on my paper.
Wow, not even doing it on my paper. Think you could put the Instagram down for now?
Yep.
Awesome.
They touched it all the way to Leslie's town.
Did you?
Yep.
I'm gonna add 720 to it. How come I'm adding 720?
Culture
That's 2 full rotations. 360 wasn't enough. 360 still would have left me with a negative angle. So I know I'm looking for. Sorry, everything seems to be all of a sudden going very, very slow and terrible. So secant of 220. So I'm looking for the cosine of 220. Put my calculator down too. I'm not going to show all my math for this one. So in my calculator, I'm going to do cosine of 220. Where are you at 220? What quadrant are you in 220? 3. Because it's greater than 180, less than 270. You're in quadrant 3. What do you anticipate cosine being? Negative. So I'm going to get that answer. I get a negative 0.07604444431, and then I'm going to do the reciprocal of that. So that's what I get as an answer. Does it change? Yeah. Actually, no. You would follow the same thing, cotan. You do a tan in your calculator, and then do the reciprocal of that. So nothing really different. Did anybody try that and get that answer? Okay, perfect. All right. Okay. Here we go. Back to exact values. Well, no, we're mixing. We're mixing. Some of these will be exact values, some of them won't. But what does this mean? What does that mean? Has to be in one rotation. So I've got a question for you. This is grade 11. Where's cosine positive? 1 and 4. So for those of you who aren't sure, remember we have our CAST rule. And the CAST rule tells us what trig ratio is positive. So we know that whatever this number here is, we know that it's positive, so it should be in quadrant 1 or quadrant 4. All right, this, if you rationalize it, is what? Root 2 over 2. That is an exact value on the unit circle. I'd much rather do this without calculators. So where on the unit circle is it? We can write it either way. Where on the unit circle in quadrant 1 is cosine root 2 over 2? Pi over 4. Okay, so, but this is what I want to point out to you. Your restriction is given in radians. So your answer needs to be in radians. If my restriction was given in degrees, then my answer should be in degrees. But my restriction is given in radians, so my answer has to be in radians. All right, but you guys told me there's another answer. There's another place that cosine is a positive root 2 over 2. You said it was in quadrant 4. Where is that located? 7 pi over 4. So you need both answers for this to be correct. This is grade 11. We did this in grade 11. We just didn't do it with exact values on the unit circle.
Oh,
Okay? Where's sine negative?
Quadrant 1, because quadrant negative 3 and 4.
3 and 4. So sine, my answers are going to be in quadrants 3 and quadrants 4. I know that. Now, do you guys remember how we deal with negatives in trig? I had a drink of water. I put my drink of water now. We have to drop the negative and make it a reference angle. Okay, I need you guys to drop the negative, make it a reference angle. We have to use our calculators because it's decimal. Make sure your calculator is in radians.
I don't remember at all.
No, I'm still looking at it. Send me the link. Send me the link.
I'm just looking up that.
What? I would. Oh yeah. I would. All day. Actually.
See? All right, so to find your reference angle, all you do is just drop that negative. And then you're going to have to use the rules for quadrant 3 and 4 to solve for what the actual angle measurement is. The reference angle is a helper. It's not a figure out or answer thing. So is your calculator in radians? Mine is not. It's turned off. So we're trying to find an angle, so we need to use second function, right? This is all just like, you know this, but we might have forgotten.
Oh. I remember.
Okay, so you have to use that second function button in your calculator, and theta reference is 1.0, my decimal went away, 1.073760909. Okay, not the answer. Do you understand why I prefer to do things without calculators? This was way faster, way easier. Now I got to do the rules. What are the rules in radians for quadrant 3? Theta is equal to pi plus reference angle. And notice I haven't rounded. I can only round in my answer. I need to use all decimal places. Okay, that's one answer. Where's my next answer? Quadrant 4. You guys told me my answers were going to be in quadrant 3 and quadrant 4.
Okay.
So this was the answer for quadrant 3. What's the answer for quadrant 4? Or what's the rule for quadrant 4? Okay, there we have it. Super exciting. All right, this is a pain. Tan of -1/3. Thank goodness. This is on the unit circle. But if you don't know your tans, then this would be hard to do. I know that tan is 1/√3 when I have an angle with a denominator of 6. And that's why the Claudius data table is kind of handy, because it taught me my tan ratios. Or you guys do this. Put them in so you can remember them. Oh, wait till we graph these. You're going to be so excited.
What?
I think I'm gonna cry.
What? Yeah, we're going to graph sine, cosine, and tan graphs, and then we're going to graph cosecant, secant, and cotan graphs.
We're also gonna graph the piercing process.
Yeah. Okay, so I know that 1/√3 is an exact value. That might not leap off the page to you. If you did this on a quiz, you have your calculator, life's good. If it were on the test, it would probably be in the non-calculator part. And that's a good indication, if it's in the non-calculator part, that it's an exact value. So we know tan is negative where? Where's tan negative? Quadrant 2 and 4. All right. So I can do a reference angle. So if I want to know where tan reference is, now if you know these values, and you might, like quadrant 2, what would my answer be? And if I know just by looking, if this is 1/√3, it has a denominator of 6. You're looking for the other one with a denominator of 6, right? So we know our answer in quadrant 2 is 5π/6. So if you know that, you can just write this down. But if you need to math it out, this is how I would do it. Do the reference angle of that. So theta reference is π/6. What's the rule for quadrant 2? Pi minus theta reference. And then what's the rule for quadrant 3? Or 4, sorry, we're in quadrant 4. I don't know what's happening here. I'm trying to see it this way. So this one's going to be 2 pi minus theta reference. That's supposed to be an R, everybody. Not having a great luck today. So 2 pi minus π/6. This would be 12 π/6. So the answer would be 11 π/6. So you can math it out even if you don't have that unit circle memorized. That's why if you can memorize that first quadrant, you can do all the math. We've done a lot of math only looking at 2 quadrants. And we can figure out the rest of it if we need to. So if your memorization is not your superpower, maybe just look at knowing that first quadrant and being able to map everything else out. Oh, that's weird. Okay, 2 over root 3. Is that an exact value? No. No. It's reciprocal of an exact value, but it's not an exact value. That'd be a nicer question. Okay, you guys solved that one. You're gonna need your calculator. Yay.
Oh, we got it.
The only way you're gonna know if you can do it is to actually do it.
And then you will know that you cannot do it.
I did the same thing.
Would you guys agree your answers are gonna be in quadrant 1 and quadrant 2?
It's telling you, it's the sign over there.
Hmm?
It's a sign. Oh, yeah.
So this is really just grade 11. We're just adding that extra layer of gradients into it.
I get error.
Me too.
Same.
How come? How
Stop
come?
walking, please.
So this, what's 2 over root 3 in your calculator? Can you guys do that? 2 divided by root 3. So because sine and cos can't be greater than 1, because if we go back to our unit circle, what is the highest y value? 1. What is this asking for? 1.154 something? So this is not possible. No solution. That's
I
fine.
knew that from the start.
You knew that from the start. So if you recognize, okay, tan is the only one that can be greater than 1.
Okay.
Because root 3 is a value greater than 1. Yeah, tan is the only one that could be greater than 1. Cos and sine cannot. Okay, last page. Holy Hannah. We're done?
Yeah.
That's it? Okay, one word about restrictions. One word about restrictions. Pay attention to them, because sometimes they'll say your restriction is like quadrants 2 and 3. And in a case like this one, where answers were in 2 and 4, we would not list 4 as like that answer as 4 if the restriction was just quadrants 2 and 3.
Cross it out.
You need to cross it out, because if you put it as an answer, that's actually incorrect.
But if you know that, if you know what quadrant that you're looking for, you need to do the math for it.
No. Like if your restriction discounts it, like if this restriction on this one was 2 and 3, I would solve for 2 and not do 4 at all. Yeah. Yeah.
Probably starting off with the low.
I also want to point out, because I have